This video is geared towards teaching you about object-oriented programming, and more specifically classes, objects, methods, and properties. I've already created the project and it is called Classes and Objects, so you can pause here and go ahead and create this new project under your solution and resume when you are done. Now let's get started with what a class is. And a class is a very, very important keyword when talking about object-oriented programming languages. I would have used that expression multiple times, and so this is the explanation. Now, a class is a blueprint for a data type, right? So for a bit more context, we have data types. We have int, we have string, we have boolean, we have char, right? And so there are times when we probably need our own data type because we need to define something inside of our program that has unique properties and even a mixture of those other base data types that I just mentioned. And so a class allows us to define our own data type, which can be a combination of these other types and properties and methods that we want. All right, so that was a very unofficial explanation of it, and I hope it made sense. But even if you're still unclear as to what it is, we're about to create a class, and I'm going to explain in detail everything as we go along. So let us say we wanted our own class called box. Now note, we already have a class. We have the keyword class that tells us, well, this is a class and it's called program, but I want another class that is not program. So I can't define a class, or well, it is generally discouraged to define a class inside of another class, but I do need it inside of the namespace. So inside of the curly braces for my namespace, I'm just going to create another class. So I'll just press enter twice, and then I will say class, and this class is going to be called box. So I want a class called box. I want a data type that, looks like a box. Now I did say it's a blueprint. So when you're defining a class, you need to say to yourself, okay, I've said I need a class, I need a new data type, I've given it a name. What does it usually look like? What are the properties? And when I say properties, they are the defining characteristics of this new data type. Well, I can tell you that a box is a 3D object, generally speaking, and a box usually has length, breadth, and height. Right? So we know 3 properties that this box will have. So to define properties, I will need the access modifier. So we looked at one when we were doing methods and we called it static. Well, there's another one. You have, public, you also have private. So in the case of a class, we can define it as public. Then we give it a data type. So the data type can be of another class or it can be of a base data type. So once again, this is me defining a data type. So if I had another class somewhere else, I could use it as a data type. No. However, I'm keeping it simple. So public, and then my data type for length would probably be something like double. And then I'm going to call it length. Then I'm just going to say get, comma, set. All right. And that's pretty much what that looks like. So public, double, length, and then the getter and setter, meaning this is allowing me to retrieve the value and this is allowing me to set a value. All right, so I can get the value from my property called length and I can set a value. And you see Visual Studio is kind of hinting at me that, I'm violating the naming convention. So let me see what they're going to tell me. And they're just suggesting that properties of classes should get capital letters. All right, so let's try that again. Now this time I'm going to show you a keyboard shortcut when defining properties inside of a class in C# and Visual Studio. You can write the word prop and then double tap tab, and then it will kind of complete that line for you. So it's going to highlight the data type. I can just press right double, then press tab, and then move on to the next one, which is my property, and this one I wanted to say breadth. And I'm using the suggested naming convention this time. Then I press enter, and then it adds it to the property. All right. So I'm going to try that again. Prop, double tab, and then double, and then tab, and then this one is going to be height. Press enter, and we're done. All right, and then congratulations, you just defined your first user-defined data type or your first class. Now that I have this user-defined data type, what do I do with it? How do I use it? All right, so let us think about how we use regular data types. When we want the regular data type, we just specify our data type and then give it a name and then maybe give it a value, right? So like when we wanted a number, we would have said something like int, that's our data type, our name, and then give it a value. True? Now we want to define box as a variable, or want a variable of type box. So box is a data type now, and we want a variable that represents box. So in order to initialize a new variable, or what we call an object, so I'm just going to write a comment here, create object of class type box. Then I'm going to say something like box. So I'm just going to call it the same way we called int, is the same way I'm just calling the data type. And then I'm going to give it a name. So I'm going to give it common B box. So it's very case sensitive. If I define the class with a capital B, then it's going to be seen differently as common B. But it could have been anything. I could have said box B, box B1, the same naming convention that we would have used to govern how we name our variables would apply here. All right. The only exception is that they can look, the case really matters a lot. So I have my data type box, and notice that it's kind of color coded just like program. So that's a class. And then box is color coded. The common B box is color coded just like num. So that's my variable, or in this situation, my object. And then I'm going to initialize it to a new instance of box. And this step is very important. All right. So without this step, then, well, it wouldn't work essentially. So if I just said box B and semicolon, Visual Studio would kind of accept it, but then nothing that we do afterwards would work. It would just throw errors. All right. So every time you're using a new class or a new user-defined object, or sorry, a new user-defined data type, which is in the form of a class that you would have created, then you need to initialize it by saying that class name, some object name is equal to a new instance of that class name again, and open and close braces. There are times you may see contents in the braces, but this is not one of those times. So I'm not going to bring up that scenario just yet, and we'll just press ahead with our objective. So now that we have our box object or box variable, and I'm going to start calling it object from now on, right? So I keep on calling it variable so you can kind of run a mental parallel, but it's really an object. Once it's of a class type and it's now initialized, it's now an object, all right? So I can say box, and then a very, very special operator that I know you've seen quite a few times, and it probably just never meant much to you. We have our full stop. So box dot, and then look at what the IntelliSense is doing. It's telling me that I have access to a property. You see that wrench? That wrench means property called breadth. I have access to a property called height, a property called length, all three of which I just defined inside of my class. All right. So they're telling me that I can get and I can set, which means that I can print box.length if I need to. And I can also say box.length is equal to some value. So I'm going to do that. So I'm going to set some values for box.length. So box.length is 10. And then I'm going to say box.width, or sorry, breadth is equal to 15. And then I'm also going to say box dot height is equal to 5. So I'm setting values here, right? So C# makes it very easy for you to create an object and then set values for these objects. So when I'm putting or assigning values, that is me setting. When I'm printing, that is me getting. So I can actually do a console.writeLine. All right, so you see that dot operator again, and notice the color coding on the word console. It looks just like the color coding on box and on program and every other class that we would have called. So that means the creators of the language C# created a class, And then this class, and I know this because after the dot operator, IntelliSense is showing me everything that I can look at in the class. It has many properties and methods. So the cube represents a method, right? So I have a method called writeLine. I also have a property called out, a property called error, a property called this, a property called that. My class only has 3 properties. This one has so many other properties that I may never use. In all honesty, I've never used some of these things in here, but the tools are there. So I'm just trying to show you that when you're creating a class, it is up to you. This is a blueprint, but then it gets initialized and then everything becomes real because then you can actually interact with the properties and methods you would have defined. So I'm going to say console.writeLine. And then I would just want to print out box dimensions are box.length, box.breadth, and box.height, right? So I'm just printing back the values. So like I said, when you are trying to view the values, you're really doing a get. But when you're assigning the values, you're doing a set. Now look at what happens if I remove the set from length and I remove the get from height. All right. So now I have an error because I'm trying to set a value on a property that only allows me to get, right? Yes, it's public, but it's saying that you're not allowed to place a value inside this property. And then it's giving me that error because it's saying, oh, that's illegal. It's read only. You can only retrieve the value. So it's not giving me an error when I'm printing it because I'm only retrieving here. All right. And then just the same way for the height, I only put it to set. So yes, I can put a value there, but I cannot retrieve it. All right. So I'm just pointing that out to you because when you're going to be interacting with other classes, well, one, when you're defining your own classes, you're going to be very careful if necessary to know what level of access you're giving to what property. So a human being probably is, well, let's say you would meet any human being unless you gave birth to this human being, you would have met them with a name. So you don't just go ahead and set name. You don't set first name and set last name, but you can get that information, right? So if you were ever to define a class that maybe you call person that looks like a human being, you're defining with properties of a human being, and a property of a human being would be a first name. Another property would be a last name, right? You probably would have first name with only get and last name with only get. All right. But then you probably have something else that can get full name, and you would never probably put a set on the first name and the last name. All right, so I put back my setter and my getter on my properties in my class, and now I'm going to execute this program. So let me just quickly switch over the startup program. All right, so our very simple program just printed out box dimensions are 10, 15, and 5, just like how we defined them, 10, 15, 5, and then we printed out our sentence. So we've been doing a lot of input-output programs, so you could actually modify this to receive the 3 numbers as input and then set the values and then do the print. So I'm going to do it. I want you to pause this video right now and attempt it yourself, and then you unpause and then we'll go through it together. All right, so I've completed that exercise. So I put in some comments and kind of rearrange the code. So it's always nice to have your declarations kind of one place. I mean, I do accept that sometimes you don't know what variable you need until you get to the point, but when you can, just try and put all of them in one area. And then I prompted for the 3 numbers, and then I set them, and then I got them. All right, so let's just run that and see how that works. So I'm getting the length, and this is going to be a box that's 10 by 15 by 5. And then it's just going to print the dimensions are 10 by 15 by 5. Now, what if I wanted to do something with those values? What if I wanted my box to tell me its volume? So I know its length, I know its breadth, I know its height, but then I wanted to calculate the volume based on the properties. Now what I can do is define a method. So I can define a function inside of my class, and just for context, notice we have the class called program and it has a function. So we went through how to define functions, and I'm just going to use the same principles, except this time I'm inside of a class, a new class body, right? So the last set of functions, we define them inside of the class program, but I don't want these methods inside of program. I want them inside of my class called box. And this method is going to return the volume. So I'm going to call it get volume. All right. So I'm going to say public, and then I want it to return a value. So remember, when it's value returning, we have to specify a data type. So I'm going to say double, and then I'm going to call it get volume. And then it is not taking any parameters, and I'll explain why it's not taking parameters. It doesn't need to take parameters because it is a part of the class that has the properties. So as a result, they're all like siblings. The properties are siblings. They know about each other. The methods are siblings with the properties. So you can actually just reference them directly inside of the method. You don't have to pass in any parameters because they're all inside of that box. All right. So, I mean, like I said, this is a data type definition. So if I have a box that has a length, a width, a height, it also has a volume. All of those are still related to this one box. So you can think of it like that. You define the class, you gave it properties, maybe you gave it a method or two functions, whatever it is, but they're all a part of any one object of this box. All right. So I'm going to say, and then notice I have the red line because it's value return. So I need to return, and then I'm returning length times breadth times height. All right, so that's how we get the volume of any 3D object. So now that I have this value, I can go back to my main function, or let me put it in the area where I'm getting the properties. And then I'm just going to say int volume. So I did say it's good to declare variables in one area unless you realize you need it somewhere else, then you just declare it. So int volume is going to be equal to our object called box. And when I say dot, you're going to notice that I have get volume now available to me. So when I say get volume, it will make that function call. So when it's executing, it gets the values from our users, and then it sets the values, and then we get the volume. But then notice I have an error here because it's saying I am returning a double, but I'm storing it inside of an int. So my bad, that needs to be double volume is equal to get volume. And then what I'm going to do is say box volume is, and then I'm just printing back the value that is inside of my variable called volume. All right. So let's go through this again. We have a box. We declared a data object called box. We're filling it with values, and then we're calculating a volume based on those values. Now look how neat this code looks. Imagine if you were to write all of those things one place, and it can get messy. So inside of your class, you can have as many functions. I could even say public, maybe I have another function that gets the area. So I'm going to say get area this time of any one side, and then area is usually length by breadth, so it's not the height, right? So I have another function. So I can do another one where I say double area is equal to box dot get area. So as many functions as I will need or want, I can define them inside of my class, and then on a need by need basis, I just declare my object, make my function call, and then get the value. And you can have void functions also, so it's not always value return. So I'm just going to duplicate this line using Control D and print out the area that I'm getting back. All right, so let's try and run this program, and I'm going to do something that I know is going to throw an error. Notice that I carelessly have been using double So I'm suggesting that my length, breadth, and height can be double. However, I am only doing an int.parse to the read line. So this is the error. If my length was 1.5 and I press enter, then I'm getting an unhandled exception error. All right. So we did talk about exception handling, where it's good to wrap it up in the try catch to avoid these kinds of errors. But just for simplicity's sake, I'm just going to change this out. So if we have int.parse, then guess what we also have? We have double.parse. All right. And if we're doing a double dot parse, we also need to have the value that is being parsed going into a double. All right. So let's just change these out to doubles. Like I said, it's very strict. And then we just change them out to double. So we have double N1 doing a double dot parse and double, 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 double. And everything is now relative to doubles. So let's try this again. So the length is 1.5 and the breadth is 3.4 and the height is 9. Just some random dimensions. So now I'm seeing that the dimensions are those three values. The area or the volume, is 45.9. So that's 1.5 times 3.4 times 9. And then the area is 5.1 because that's 1.5 times 3.4. So now we have some data type that represents a box. But guess what? What if we had two boxes or more than one boxes, or we had a collection of boxes? The fact is that we can define as many boxes as we need. So I'm going to say this is box, and then there's a second box that I need to be aware of or work out dimensions for. So I can say box 2. So there's nothing stopping me. So it's just like how we can have multiple integer variables, multiple string variables. You can have multiple objects, and my spelling is defeating me. You can have multiple objects of the same data type as long as the names are not the same. All right. So I can have box 2, box 5, box 10. Now imagine trying to fill in the dimensions of a warehouse full of boxes. So you know that there are 10 boxes and you have to write a program to allow them to enter the dimensions for 10 boxes. Then you're going to have box 2, box 3, box 4, box 5, and then you're going to have prompts per box, because then for box 2, I'm going to have to repeat all of these steps just to make sure that I'm getting for box 2. So there is an easier way. I'm just, giving an idea of how tedious it might get, but I am just saying that is what at this point we would have to do. So I'm just going to proceed with box 2. So we have the prompts for the values for the box dimensions, then we're setting and printing the values, or at least setting and calculating the values for box. So I'm just going to duplicate all of this, and I'm going to do it again underneath, right? But then this time I'm going to change these out. So I'm not going to redeclare N1, N2, and N3. So like I said, if you have to reuse a variable, you can actually just reference it by name after it has been declared, right? So we declared it here. We're not declaring it again. We're just using it again. So I'm just making reference to it. And then I'm changing these out to box 1. So is it box 1? Box 2, sorry. So we're changing these references out to box 2. And then once I'm done this, I'll just explain quickly exactly what is happening here. And then I'm going to duplicate all these print lines where I'm going to be printing box 2 dimensions. And then note, I'm going to have to override. So I'm not going to do an override, but I'm going to show you that you can actually print directly from a return, right? So up until now, I would have suggested that you put the return value. So remember that get volume is a function that returns something. So when it returns that value, I noticed I didn't use a variable this time. I just returned the result of this calculation. And then that result of the calculation is going to get stored inside volume. Now, down here, I'm printing volume and I'm printing area, which we know were for box, the first box. I'm going to remove those declarations for the second box. So all I'm setting is the height, the breadth, and the the length, but then I'm printing box2 dot, and then I'm just going to call the function right there, get volume. And then I'm going to print again box2 dot get area. All right. So then I'm just showing you that you can print the variable, you can do the return call, get it, store it in a variable, and then manipulate the variable, which might be more desirable if you have, other things you need to do with the value. But then you can also just return it and have it print directly inside of your print operation, right? So you have those two, and of course you have to know when you're using which method. So let's run this program. Once again, we have two boxes. So I have two boxes of the data type that I just created called box. I'm going to prompt to enter values for the first box. And then I'm going to calculate the volume and the area. Then I'm going to prompt again to enter values for the second box. So, I can modify the prompt to say for box 1. All right, so I'll just do that. And then I'll repeat that for the prompts for box 2. And then after getting the values for box 2, we're just setting the dimensions accordingly. And then we're just going to print box 1 dimensions, box 1 area, box 1 volume, and then box 2, and box 2. So I'm just adding these so that we have some visual cues as to which values are for box 1 and which values are for box 2. So let's run this and see how that works. All right, so I've already entered some of the values, 5, 6, and 3 for dimensions for box 1. And then I'm going to say 5, 4, and 10 for dimensions for box 2. Press enter, and then we can see here, box 1 dimensions are these 3, and then box 2 dimensions are those 3, and those are the calculations. So you see that I'm still getting the area and the volume, even though I'm just printing directly into the console right line, the return value. All right, so make sure don't get confused by the curly brace and that. We're making a function call inside of console.writeLine here. So when it gets to this line and it starts writing the text, it realizes that, oh, I have to make a function call. Let me go to the function, and then that's going to return some value. And then whatever it returns is what gets concatenated into the string that is being written to the console. So like I keep on saying, there are many ways to do things. I think that, getting it back and storing it in a variable is much cleaner, much more, much easier to read than something looking like this. But once again, you have that method available to you. Now, as a final act, I'm going to display to you the best way to handle your classes. So I would have had to go through the painstaking explanation of saying why we should not define another class inside of this class, right? So we have class program, and I had to go through, quite a bit of code restructuring to make sure that I was not inside this curly brace, but inside of the namespace curly brace. And it is actually best practice. It leads to much cleaner looking project files and code, and just code in general, when you create a new file per class file. So notice that we have a class called program. We have a corresponding file in our project called program.cs, which then means any class that you create, it is best practice to create a new file, call it that class name .cs, and place your definition of a class inside that file. So I'm actually going to do that right now. So I'm going to take this class that we just created, and I'm going to cut it. So all of the code associated with the class, I'm just going to do Control X, and I'm cutting it from inside main. And then if we give Visual Studio a few seconds, and everything is going to go haywire. It's going to be like, oh, I have a definition for a data type here that doesn't exist. And then we're going to say Visual Studio, it's fine. We know what we're doing. So we're going to go over to our project, classes and objects, right click, and then click add. And then what we're doing is adding a new class. You see that? Class. So we click class. And then once again, whatever the name of the class is, it is best practice to give the file that name. So I'm going to call this class box. So then it's going to go ahead and create a new file, and it's going to even go ahead as far as filling in the name of the class called box, because contextually it's already naming the class. So I'm just going to replace this predefined code, and notice it's saying 4 references, and that's because just by me creating that class and box, no properties or anything, in my main, it automatically detects that, yeah, the data type is box, so I know what I'm doing. But then it has no properties, it has no function, so everything else is still haywire. So I'm just going to replace this block of code with the class that I just created. And then when I go back over to my main, then everything is fine. So once again, when we're about to create a class, it's actually better to just go to our project, right click, go to add, click class, give our class a name. So let's say I created a class called person, all right, and then do all of our definitions, all of our properties. And I just filled out 3 properties quickly. I didn't want to bore you with writing them, so you can pause and write them off if you need to. But they're first name, last name, and age. And then I'm going to declare another one. And this time I'm using a different access modifier. And this one is going to be called private. So private would be salary for argument's sake. So double and salary. All right. So I'm defining these as public and this as private. Now, when something is private, it means that nothing outside of the class can access it. You cannot directly access this property from the object. All right, so let me just put that into context for you. So I'm going to go back to program. I'm not going to do too many modifications because person is coming on the tail end of this lesson, but let's just see what happens. So I'm going to say person, and notice it detects person because it's in a class file, it's in the same namespace, so they know about each other, right? They're siblings. So person, and then as usual, I have to declare a new object of person. So I'm going to say capital P person, that's the name of the class, common P person, that's the name of the object, is equal to a new instance of a person. All right, so I can say person, the object, and say dot, and then IntelliSense is showing me exactly what I can access. I can access the age because that was public. I can access the first name and last name because those two are also public, but I cannot access the salary because it is private, right? So even if I go as far as writing salary, because I'm defining Visual Studio and C# and I'm going to say, right, I want to see salary, then it's going to say that you cannot, it is not accessible because of its protection levels. So because I said it's private, that's private information, I can't just go on and say, I want to see salary. All right. So usually when you have private properties or private member fields inside of a class, then you make what you call getter function. So we already defined that we can have a default getter and a default set once we define our public property. But then when it's private, you probably don't want to do it like that. So you can actually do something like defining a function, and I'm just going to call this public and call it double, and I'm going to say get salary. And then this public function that I should be able to access when I say person dot will return salary. So return salary. All right. And then what if I needed to set the value for salary? Remember, it's private and it doesn't have any getter and setter. So usually they would actually create another function and they call this one set. So you can say public double get salary, and this is going to return, but then this one can be void because I don't need to return anything when I'm setting the salary. However, I'm going to require that you tell me how much salary I'm setting for this person. So I need a value from you. So I'm going to say send me a parameter, and I'm going to say give me salary with a command S, and then no return, but I'm setting the capital S salary, which is my private member field, to have the same value as the salary that is coming in through the parameter. So salary is equal to salary. So a good naming convention actually when it comes to private members is that you use underscore and not capital letters. So the public accessible ones would have the capital letter, but once it's private, you use an underscore and common case. So let me just change that out. And I mean, you saw that it worked either way. So it's not a matter of it working versus not working. It's just a matter of this is the standard. So if somebody else comes along, looks at your code, they know exactly what they're looking at a glance. All right. So private double salary, that is our one private member field. And we need a function to get the value that is there. And we need a function to set a value in there. So back in the program, I can say person dot, and I will only have access to any methods or properties that have the public identifier or access modifier, indicator on their declaration. So that's it for this very, very So that's it for this quick introduction to classes and objects in C#. I'm going to encourage you to just think of anything. Think of your pet and then define a class called pet and then start writing out the different properties. And I like to think of the properties as the nouns and the methods as the verbs, right? So the noun would be like something that is there. So a box is always going to have a length. It's always going to have a breadth. It's always going to have a height. But then getting the volume and getting the area, or in the situation of the person getting the salary or setting the salary or even getting full name. So let me just type that one. I want you to complete this. String, public string, get full name. So I want you to define this function to get this person's full name. And I want you to share your code with me, and then we can go through any difficulty you had together. So once again, the methods are more like verbs because this is an action. Getting the full name is an action, but the name is always there. That's more like a noun. All right. So that's a challenge for you. Let me know if you have any difficulty.